Hey everyone, and welcome back to the second workflow tutorial. In this video, I'm going to look specifically at how to navigate CAD files that we might receive that come along with a variety of XREFs and potentially extraneous image files, lines, and other info. So I have a workflow that I use to clean up CAD files before I import them into Rhino. And I'm not sure that this is necessarily the best way, but it works for me. And if anyone has other golden tips, I'm always happy to hear them. So the file I'm using today is a competition file that is privacy protected, so I can't tell you much about the location or the firm or the content, but I will say that it wasn't produced in North America and it is one of the cleanest and most efficient CAD files that I've ever received. But nevertheless, even with beautifully drawn CAD files that look perfect, there's always a little bit of work to be done to reorganize and prepare for 3D. So because of the privacy restrictions, I can't provide this as a working file for you. This tutorial is going to be more about you taking a look at my workflow, but I am going to create a cheat sheet of the commands and processes that I'm using, and I will include that as a download link in the description. Okay, so let's open up this CAD file. The first thing that comes up is this panel that says the refs can't be located or read. Let's take a look. In the XREF palette, we see all of the references that are currently linked. All of them have this little yellow danger sign, which means they aren't properly linked to the file. Now we could go through and link each one, but I've gone through these already and they're mostly XREF sketches or PDFs that aren't going to be helpful to us in 3D anyways, so I'm not even going to bother detaching these or relinking them. Now the CAD file contains a lot of context that is far outside the design area. This file is meant to serve as a comprehensive context plan for the competition area, which encompasses all of these blue buildings and the lighter colored trees. For the purposes of this exercise though, what we'll do is draw a rectangle around the area we want to focus on. I'll use the rectangle command, REC, and center it over top of this central plaza area here. After selecting our focus region, let's use the selection windows to eliminate all of the extraneous context surrounding this. It might seem aggressive, but when we're working in 3D, it's important that we keep our files as clean and as meaningful as possible. So unless we're creating large aerial views, none of this context would ever be visible and it contributes very little to the design. Just like in Rhino, when we select from upper left to lower right, everything completely encompassed within the selection window is highlighted and can be deleted. If we go the opposite direction, we create a crossing window. Now we can turn this rectangle into a trim object. TR is the trim command. Then we can either draw a line through all of the objects to trim or right-click and select crossing. Either will work. I'm going to use crossing just for fun today. I'll speed this up and work between deleting objects outside of the boundary and using the boundary to trim. The file's pretty clean, but if we look in the layers panel, there's still an overwhelming amount of information here. If we were to save this and import it to Rhino right now, all of these layers, whether frozen or not, would import alongside everything else and would create a muddle of a file. My solution for this is to create a new file, Control N, select the template, write units and switch to meters. Now go back to the original file, select everything, and use the command copy base to select a specific base point. I'll use 000. In the new file, use the command paste clip and enter the same coordinates as the base point, 000. Now the line work is in the exact same location. This is useful because if you had an updated file with new line work, you could easily copy them directly and they retain the same orientation. Zoom extends and we can see now that we have a very clean file with just the layers that we're using and without the unlinked XREFs from before. Carrying over as little extraneous data as possible is the key to a clean transfer between CAD and Rhino, so let's move forward with optimizing this line work. Select everything in the drawing space and change all of these options to by layer. This ensures that the appearance of objects is consistent within the layers. Now let's check the Z depth of all these objects and lines. If your properties panel isn't docked here like mine, you can access it with the command MO. Using the dropdown, we can examine all the different types of lines and objects to ensure that they're all set to 0. If you come across any objects that say varies, just change to 0. Now we know that all the lines and objects are set to the same Z elevation, and we don't have to worry about random objects in space. If we run our mouse over these polylines, Autocad highlights all the joined polylines. Most of them are great, but there are a few that aren't yet joined. To focus on a layer that needs work, we can use the Layer Isolate command. I always grab it from the toolbar up here, then click on a line in the layer I want to isolate. We could join these lines one by one, but there's a command called pedit, PE, which stands for Polyline Edit. Right-click and select Multiple, then select all the lines. Enter Yes, J for Join, Enter, Enter, Enter. All of these objects are now joined, and we can unisolate using this up arrow here. I'm going to go through all the rest of the lines here and just make sure that I join them together using pedit. Once you're sure that all the polylines are joined, we can finish off this process with a purge audit routine. I don't remember exactly where I picked this up, but it works a treat to eliminate overlapping lines, get rid of extra objects that somehow make it through the process, and generally gives you a very positive feeling of taking out the trash. Start with purge, PU. Click here and purge all. Close. The next command is -PU, which is a secondary menu with more extensive options. Enter R for Reg Apps, that stands for Registered Applications. Enter, enter, put N for no, and press enter again. If you accidentally accepted Y for yes, Autocad will ask you to confirm every single application on the list. It doesn't take forever, but just about, so always make sure you select no. The next command is AU for audit. Fix errors? Yes. No errors found, but believe me, that will change. Last is OV for overkill. Select the entire drawing space and it will look for objects within this tiny tolerance, which are basically overlapping or duplicate objects. Press enter and we see a whole bunch of duplicates were found and deleted. Now we run through this routine one more time just to be sure that we've got everything. Things should be pretty clean, so let's save this file, and we're going to backsave it as an Autocad 2007 file. You can use later versions, but 2004 or 2007 has always worked well for me with no import issues, so I'll stick with this. Now let's open up Rhino and import our file. Making sure we're in the top view, type in units and check that we're in meters to match our CAD file. Press OK, then File, Import. Press OK, then File, Import. Select our file, and Rhino has no problem reading this. But it's not anywhere that we can see it. Where did it go? Use Zoom Extents to see all of the objects in the model space. We can see this line work came in somewhere very far from the origin. This can create problems for modeling and rendering in the future, so I always try to move my models directly to 0, 0. I'll add a point to the corner here and move this down to the origin. Keep in mind that if you import new line work later, it will come in at this faraway location, so you'll always have to shift it down. But in this case, with a rectangular frame, that should be no big deal. Let's just double check the dimensions here, DI for distance, and measure this path. It looks pretty spot on. Now, you might think that we're all done here, but that's not it quite yet. Let's move over into the Layers panel and create a new layer with today's date on it. We can then move all of our imported layers into this parent layer. If we ever import other 3D objects or line work into this file, we can keep our file organized by keeping everything nested together by date. Okay, we have a little purge routine for Rhino 2, PU for purge, and there's not much to get rid of here, but that's okay. Let's see if there are any duplicate objects left over from our CAD import. Cell-dup is the command to use for that. Nope, nothing to see here. But just in case, let's use cell-dup all. Nothing there either, which is a great sign. Now for the final command, cell bad objects. What does this mean? We have a bunch of bad objects, and what are we going to do with them? Well, first let's use the selection panel and invert the selection, Then hide all of the good line work. Now we just have the bad objects in front of us. Oftentimes when we import geometries, particularly splines, Rhino has a hard time with them. But the good news is that at this stage, it's very easy to repair. I just explode them using X for explode, and then rejoin using J. Let's check to see if that worked. Yep, all good. That solved the problem. We don't have to worry about these creating bad geometries in the future. If you still had bad objects remaining, you might have to redraw them. So unhide the good line work, and that's it for this workflow. If you need a review on how to get started with surfaces and extrusions, I will add a link to the modeling tutorial from the first series. That video has all the commands you need to know to produce a great 3D model. Thanks for watching, and see you in the next video.